Hi, it's Evan, and this is my favorite Lego piece. Now you're thinking, that's not a Lego piece. Yes, it is. This is called Interface A. It's set 9750 from 1986 and then again 1987. Basically, this is a robotics interface. This is Lego's first electronics robotic interface. Before this, they had analog mechanical versions. And this goes between an 8-bit computer, like an Apple II, BBC Micro, Commodore 64, IBM PC on one side, and your Lego peripherals, 4.5 volt peripherals, such as motors, lights, touch sensors, optical sensors on the other side. This is no intelligence. It passes data through. And I love this thing. It came out in 86 in the UK and Australia. 87 it came to America. The story behind it is sort of two parts. There's a European part where Lego worked with the British government and their computer education program, and a couple companies and colleges out there that ended up producing commercial hardware that worked with Lego models but wasn't sold by Lego. Lego also partnered here in the US with MIT, the Massachusetts Institute of Technology, and a company called LCSI. And that those two separate partnerships resulted in this piece of hardware. So it was sold in the UK and Australia and some of the European countries to work with an application called Lego Lines, and then in America to work with Logo. It also worked with BASIC, 6502 assembly code, a language called COML, C-O-M-O-L, or really anything that could talk to a parallel port. It was a later version, 16-bit version in the early 90s, Control Lab, that worked with serial connections. So this is about the size of my forearm, right? Only weighs a pound or two. It's got ribbon cable goes in here, power supply there. It's got an emergency stop if things go wrong with your model. You need to throw a lever quickly. That's an always-on test port here. It has 0 through 5 are outputs for lights and motors. Ports 6 and 7 are inputs for touch and optical sensors. It's not meant to be user serviceable. It has plastic rivets on the front and back. You could drill those out if you need to and open up the box. And I don't know if you can see it on camera, but it does say here, copyright Lego Group. And it does have the Lego logo sort of molded into the front of the case here. So I love this thing. I didn't discover it until about 2016, but I remember when I was 12 years old in 1986 telling my parents I wished there was a way to connect my 8-bit computer to my Legos. Turns out there was. It came out that year. I didn't know about it until much, much later. It was only sold to schools. It wasn't sold commercially, and it was very rare. But it works great. So the next part of this video, I'm going to show you how it works. Let's do that. So here I have my Apple IIe Platinum and one of these boxes, 9750 Interface A, as I mentioned. I'm not going to cover the software now. It works, as I mentioned, it works with Apple II, BBC Micro, C64, IBM PC, some other things, and a whole bunch of different programming languages. Just going to focus on the function of the box for now. Power strip on, put the computer on, the floppy. And run a little program I wrote. So I mentioned this is the always-on test port. We'll start there. If I plug something in there like a motor, it just works. Turn the wire, it works the other direction. This is good for part of your model that always needs to be on, like a fan or a light or something. Anything you want on that does not need to be programmatically controlled. I'll show you a light now. Put it in here and voila, we have a light. Now, as I mentioned, port 0 to 5 are outputs. So I turn this on, the red light LED comes on beneath it, and whatever's connected to it turns on, the light or the motor. Now, we also have A, B, and C for outputs. That's if you want to be able to control a motor in both directions. If you plug it in vertically, it only spin one direction unless you physically turn it around. But by plugging it into A, you could alternate which one's turned on and spin it the other direction. You see it changes light over here and the motor goes the other way. Now I'll demonstrate the inputs. This is a touch sensor, 6 and 7 both work the same. If I plug it in here, the light is off because it's not currently being touched. If I press that, boom, light comes on, off, on, off, on, off. Easy enough. This is an optical sensor. Now since I'm not currently covering the input, it'll see light, it'll be on. See, it's on. Cover it, off, on, off, on, off. Lastly, as I mentioned, the emergency stop. You have your model running, something catastrophic happens, something breaks, someone sticks their finger in a moving part, you go bam, off. Your software will keep running, but the box is disabled. Everything's clear, you're ready to go again, turn it back on. And that's how it works. It's that simple. This is true no matter what language you're using to control it. I happen to be using BASIC, but any language will work the same with the box. I'm going to make 5 more videos in the near future. The next one will be about how to test the box if you don't have a computer attached. A lot of times people find these, advertise them as is untested. Turns out there's very easy ways to test it without a computer. I'll also make 1 video each for each of the 4 major computers it works with, and then we'll get a trend going. That's all for now.